Good afternoon, everyone. Today we're going to continue our discussion on a new lesson, which is portfolio optimization. So may I ask you first, class, what have you learned in your previous subjects about portfolio optimization? Did you learn how to compute for portfolio returns and portfolio risk? I'm sure you have discussed in your classes that it pays or it makes sense to, as far as investment is concerned, it makes sense to carry a portfolio of asset instead of just a single asset. Okay, and there are, of course, reasons for that. But I'd like to know, class, in your previous subjects, did you really learn how to compute for portfolio returns? So instead of, if you have 10 assets, okay, and you like to create a portfolio where returns is maximized, and did you learn how to compute for portfolio risk? Because part and parcel of portfolio optimization is being able to determine what is the returns of your portfolio and the risk of your portfolio. Okay. May I have from your chat, class, if you learned how to compute for the portfolio returns and portfolio risk? If I ask you now, what's the formula for portfolio returns? Can anyone answer that, class? How do you compute for the returns of a portfolio? If you have a portfolio of 5 assets and you'd like to compute for the returns of your portfolio, how do you do that? Anyone, please? Anyone, please? From your previous subjects, meron na kayong FinCapM, di ba? Capital markets. Meron, I think you also have investments analysis. Anyone? Okay, otherwise, class, I'd like you to put in the chat box. Kindly confirm if yes, you know the formula, or no, if you don't. I'd just like to have a feel of what the class knows or does not know. You haven't met this before. Okay, kindly please answer to the share your answer with everyone. It doesn't matter, class, if you don't know. No need to be ashamed about it. Okay, thank you. All right, so okay, thank you for your honesty, class. So most of you said no, you don't know, but there are some answers here. I saw here an answer. Okay, Vince, what do you mean by weighted average?
I think it's more of the probability or times the returns from like the asset, I guess.
Okay, probabilities. Okay. But let's say you have a basket of assets and you know how much you invested in it. You have, let's say, 1 million pesos, and then a certain percentage is invested in this asset, etc. Okay, so you're not talking of probabilities here. You're talking of specific weights that you have that you have invested in a particular asset. So in that case, how do you compute for the returns of your asset? Okay, you have the right idea. It's weighted. So let me just define for the class the returns of a portfolio. Now, this is very important, class, for any Fin student. It's just like our ABCs. It's our fundamentals. So if we graduate from the university, not even knowing the formula for the returns of the portfolio of assets, then that's something that's non-negotiable, class. That's all I can say. It's highly unlikely for a finance student, not to know even how to compute for the returns of a portfolio. Okay, consider that as our ABCs. Okay, one of our ABCs. These are things that it's not nice to know. It's fundamentally, class, it's fundamentally required that we know how to compute for the returns of a portfolio. Okay, so the formula, class, is, let me call it, okay, R, return of a, well, it's, what's happening here? Okay, okay, wait, class. Okay, so the return of a portfolio, okay, it's equal to, you just have the sum of the weights of the portfolio multiplied by the return of each asset. So this is pretty straightforward, where your I ranges from 1 up to your N. So it's just the sum of your weighted returns of your asset. So that this is very easy. If you just, for example, you have asset one, you're invested in asset one 10%, asset two is 30%, asset three, just to simplify this, it's 60%. And the return here is, let's say, 4.5%. The return here is, let's say, 6%. And the return here is 7.5%. Okay. So these are your weights. These are your returns. So the return of your portfolio is simply the sum of all these products here. 10% of 4.5%, 30% of 6%, and 60% of your 7.5 returns. If you sum that up, you'll get your portfolio returns. So pretty straightforward, class. No, it doesn't matter if you have 10 assets, then you'll just have 10 items here. You'll get the weight of the 10 assets, and then the returns of each asset, and then multiply it with the weights, and then sum it up. The weight should total 100%. Okay? So others will call this K, where K is the returns also. So you can see in other texts, it's W sub I, K sub I, they're the same. You're just summing up your weighted. So you're correct, it's weighted returns because you're multiplying your returns by the weight of the assets as far as the portfolio is concerned. Okay, may I have your chat, please, if the formula is clear? Kindly chat. So I hope your no has turned into a yes. And don't forget that, class. This, as I said, is fundamental to your field, finance. Okay? It will be quite, let's say, embarrassing if we were asked, for example, you were applying for a job and you were asked about this formula. It's just like 1 plus 1 for us. Okay. All right. I hope that next time you're asked what the return of a portfolio is, you'll be easily able to define what the return of a portfolio is. Okay, so the next question, class, is how about the risk of a portfolio? Now, this can be more difficult. Okay. And we'll spend maybe 30 to 45 minutes just discussing this because I want this to be very clear to you. Because the concept of portfolio optimization requires for us to understand the concept of optimizing both the risk, the returns, and the risk. For the returns, it's very easy. That's very straightforward. Now, for the risk, it's quite, let's say, it's more tedious. It's more involved as compared to the computation for the returns. All right. So once again, I'd like to chat. Have you encountered, class, in your previous subject, how to compute the risk of a portfolio of 2 assets, 3 assets, 10 assets, even 20 assets, class? How do you compute for the risk? Kindly chat yes or no, please. Okay. Waiting for the others to key in their answers. A few more seconds and then I continue. How about the others? I'm not getting any response from the others. Whether you know or not, class, kindly just give your feedback. Okay. So mostly it's no. I think 100% no. Okay. Although I didn't get the response of the others. All right. I assume that you don't know the computation for the risk of a portfolio. Okay. And then let's commit ourselves to, okay, to knowing and telling ourselves that at the end of this period, you should be able to define the formula, the risk of a 2 asset, 3 asset, 5 asset portfolio. Okay. So in general, class, in general, the risk of a portfolio, let me use another ink. Okay. The risk of a portfolio, let's name it sigma, sigma squared, which is a measure, the variance, or you can express it as sigma p. This is the variance, this is the standard deviation. P stands for your portfolio. Okay, so the risk of a portfolio, either measured as your variance or your standard deviation, the standard deviation is merely the square root of your variance, okay, as you should know. Okay, it's equal to, okay, so so the variance is equal to, okay, the formula is quite, it's more involved than the, okay, take a look at this formula. So this is the formula for the risk of a portfolio. Please remember this, class. Okay? Please remember this. Of course, you'll be able to understand this if you know the parameters involved. Okay, let's take a look at them one by one, class. This is very easy. Okay, we know W here. W here referred to your, isa na yung ano ko, W here referred to your the weight of your asset. So if you have a portfolio, let's say the value of your portfolio is 1 million pesos. And the amount you invested in a particular asset, let's say asset A, is 100,000. So that means that asset A, okay, carries a 10% weight as far as the portfolio is concerned. Okay? Now take note that you notice that you were doing pairs here. A pair. You have double summation. You have your asset 1 and your asset 2. Okay? So this is the weight of your asset 1. This is the weight of your asset 2. You're multiplying it. And then what's this, class? Can anyone tell me what sigma ij stands for? What did you learn in your basic stat? So that's from your basic stat. So this is sigma ij. This is what, class? And what's the formula for your sigma ij? Anyone, class? Sigma ij, what's that? Okay. Let me see. There's an answer here. All right. Thank you, Christine. You're correct. This is the covariance. But before we go there, so what's this, class? What's this? This is your, oops. What's this, class? Can anyone tell me what's this? All right. Thank you. Thank you, Vince. So this is the variance, diba, class? Variance of I, whatever your I is. This can refer to the returns. Okay. So let's just look at this in terms of returns. So variance to, no? Variance. How about this? Okay, take note that you have here two subscript, I and J. Okay. This actually, the variance of I is actually equal to, all right, so please recall this. I'm sure you have met this in your stat before, but maybe you did not bother understanding it. The variance of I is just the same as the covariance of I. Covariance of I with I. So I with I. And take note, you don't put 2 here. But for this one, you have a single subscript here, I. You put squared here. So you don't write it this way, sigma I, and then squared. This is this is not the covariance of I with I. The covariance of I with itself, I with I, is written as sigma II. So nothing here. And this is equal to sigma squared the variance of I. So these two are the same. Okay? Sigma II and sigma I squared. All right. What's the formula for sigma for the variance of I? What's the formula for the variance of I? Anyone, please? What's the formula, class? For the variance of I. This is equal to, class, I was expecting some quicker answers from your end. Kasi this is even high school math, okay? Class, variance of I, sigma squared sub I. Class, hello? This is basic stat, class, basic stat. Hello? Anyone, please? Anyone? Or let's have some quick answers from your end. Waiting, I'm waiting, class, for your answer. Okay, Vince, kindly unmute and tell us what that means.
So I is the X, right, sir? And then A. So, so we basically find X minus mean, then we square it for each.
Yeah, okay. So class, that's a basic question. I was expecting you to be able to answer that. So if we're dealing with returns, so you get the individual returns of your asset, R sub I, and then we subtract it from the mean. Okay, the mean of your asset I. So this is the mean. Okay, we get the summation, the sum of this deviation squared. Okay, we square this because if we don't square it, class, if we just get the sum of this, it will give us 0. The sum of your individual returns minus the average, if you just sum this up, this will give us 0, because that's the definition of the mean. The mean is supposed to be the center. Okay, all right, so we square it first and then get the sum and then divide by n. So that's the variance, class. I don't know, actually, class, I don't know how to react because this is supposed to be very basic. Okay, it took us around 10 minutes for you to answer what the variance is. I don't know why you're not able to answer what the formula for variance is. Okay, so this is just the same as I said. This is the same as sigma I sub I. Okay, the variance of I is equal to the covariance of I with I, and the covariance, class, is defined as the summation of your R sub I minus R times R sub I minus R, the mean of R. Okay, so it's just like getting the squared, because you're cross multiplying the deviation of your individual returns minus the mean, and then multiply it by the individual returns minus the mean of your asset. So if this was J, if this is covariance of I with J, this will be equal to the summation of the deviation of I times the deviation of J, R sub J, okay, over N. Over N. Okay, class, I don't want to spend too much time on this because this is pretty basic stuff, class. This has been your lesson in your elementary days, in your high school days. So I feel agitated, class, if you're not able to answer, class, a very basic question. Okay. All right. So let me go back now to the formula for, please cooperate, please answer, class, for basic questions like that. Okay. So let me go back. So I said, class, the formula for the variance of your portfolio is a double summation of W sub I, W sub J, covariance Ij. Okay, so we know now how to compute for the covariance. Okay, so in general, the covariance, class, is just the cross product. Okay, we said that this covariance of Ij is the cross product, the sum of the cross product of your return of asset I minus its mean multiplied by the return of asset J minus its mean. Okay? And then divide by N. So this is your covariance, this one. All right, then how do we now compute for the risk of the portfolio? So remember, the risk of the portfolio is your double summation W sub I, W sub J, covariance I sub J. Okay, let me pause for a while, class. Do you understand the formula, class? Kindly chat yes. Do you understand this formula? Yes or no only, class, please. Yes. Okay, let me see. Let's see if you understand it. Raul, thank you for answering. But may I ask you, Raul, if you have a two-asset portfolio, how do you now perform this operation? So let's say you have two assets in your portfolio. Two assets. So asset 1 and asset 2. Asset 1 has weight 1, asset 2 has weight 2. Okay. Okay, Raul, how do we now perform this operation? Dalawang summation, you have double summation, class. Any idea, Raul? Okay, where's Raul? Malyari?
Hello, sir.
Yes. Okay, let me repeat my question, class. No? Okay, just a yes or no. Just be honest, class. You're given two assets, asset 1 and asset 2. If I ask you, class, using this formula, what will be the variance? Okay, because the risk of a portfolio can be measured in terms of variance or standard deviation. Okay, I want everyone to chat once again. Do you know how to perform this double summation, this equation, given your two assets? Okay, chat again, yes or no, please. Please be honest, class. It's okay if you don't know, class, because that's what I want to know. Because if I ask you, if you answer yes, and then if I ask you how to perform it, and if you don't know, then that means that you're being dishonest. Ulit, class, this is the formula. Okay, again, this is the formula for the variance of an N asset portfolio. If you only have two assets, what will be the equivalent risk measured by the variance of a two asset portfolio? Okay, so about the others, class? Even the feedback, class, of a yes or no takes long. We have we have so many things to discuss today. I would that you be more, uh, class, immediate in your response. No, no, no. No, no, no. Please listen to the question. Okay? Listen to the question. I'm not going to answer the question for you. My question is, given this formula and given these two assets, would you know how to generate the variance of the portfolio? It's as simple as that, class. Don't ask me to answer my question, okay? Just yes or no, class. Just yes or no. Okay, that's it, class. Very simple. No. Okay. How about the others, class? Kasi a while ago you said yes. Maybe you misunderstood my question. Okay, so now I'm going to discuss the answer to that question. Okay? Are we clear, class? Are we clear? Okay. So the formula for the variance, class. This one. Summation, W sub I, W sub J, then the covariance of Ij. If you have two asset portfolio, class, how do you now compute for the variance of the portfolio using this formula? Okay, so the way to do it, class, is because you have double summation, diba? Double summation, summation, W sub I, W sub J, covariance Ij. Note, class, I don't have a 2 here, okay? The covariance is already spelled out by I and J. Okay, so don't make the mistake of putting a 2 here. All right, I is equal to 1, J is equal to 1 up to N. All right, so you have a two asset portfolio, so you will be spelling out a pair. Okay, so you have asset 1 and asset 2. So let's first identify the pair. So first, 1 with 1. So that's one pair, 1 with 1. Okay, take note the formula calls for I and J. And the double summation calls for defining I and defining J. So let's first pair 1 with 1. Okay, and then let's fix this. The next one is, this will still be 1, and this becomes what, class? Your J becomes what now? Your J becomes So that becomes what, class? Of course, 1 with 2. So that's our next pair, 1 with 2. Okay, so next. Can we still continue with 1? 1 and what? No more, class, because it's only 2 asset portfolio. We do not have another third asset. So this one is not non-existent. All right. So after we have finished all ones here, we now go to 2. Let's make this 2. So once again, pair this with 2, and we start again here with 1. 2 with 1, and then the other one will be 2 with 2. Okay. So it's just like a pairwise. Okay. Just pairing your numbers. Okay. Good. So we have 4 pairs: 1 1 1 2 2 1 2 2. Okay, now that we have identified the pairs, then it will now be easy to set up our portfolio variance. So sigma squared of your portfolio variance is equal to, so let's start here, W1. So let's substitute 1 1. Okay, your I will be 1, your J will be 1. So it will become W1 and W1, right? For this one, it's sigma 1 1. Okay, so we're just substituting. We're just exploding this formula. That was my question a while ago. Do you know now how to compute this formula knowing that your assets is 1 and 2? And we're now solving it, class. Okay, I'm now showing you how to do it. Okay, a while ago I asked you if you know how to do it, and you said yes. Pero hindi nyo yata we're not able to understand my question. Okay, next, class. The next pair is 1 with 2. Okay, so let's simplify this. This is just W1 squared, right? W1 times W1 is just the square of W1. This one, class, sigma 1 1 is your variance of 1. Here, class, 1 with 1. Okay, the covariance of 1 with 1 is the variance of 1. There. Okay, the next, W1 2. So let's substitute W1, W2, and then sigma 1 2. All right, so this one we can simplify. So we just put here W1 W2 sigma, that's the covariance of 1 with 2. Okay, all right, next, 2 with 1, this one. So this becomes W2 W1 covariance of 2 1. All right. Okay, I forgot to ask you this a while ago. Okay, let's go back here, class. Okay, where's my other Word file here? Okay, the formula for, where's the formula? I lost it. Okay. Recall, class. Recall. The covariance of 1, 2 is equal to summation of your R, return of asset I, return of asset 1, minus the mean of asset 1, times the return of asset 2, minus the mean of asset 2, over N. Okay, my question is, what is the relationship between sigma 1, 2 and sigma 2, 1? Okay, kindly chat, please. What do you think? Is sigma 1, 2 greater than 2, 1? Is sigma correlated with, what's the relationship between sigma, covariance of 1, 2, and covariance with 2, 1, class? Let me repeat my question. What's the relationship between sigma 1, 2 and sigma 2, 1? Okay, why are they the same, Jerome?
Because the variables are also the same.
The variables are the same. Are the variables the same? R1 and R2, are they the same?
I mean, they just switched, sir. The positions
right.
just switched.
Yeah, correct. Commutative, right? If this was 2 and this was 3, it doesn't matter if you multiply 3 first and then 2. Right? By principle of commutativity, we know, class, that sigma 1, 2 is just the same as sigma 2, 1. All right? Kindly chat, please, if that's clear, class. Sigma 1, 2 is just the same as sigma 2, 1. Okay? All right, good. So I hope that's clear to you, class. So this one, okay. So this one, class, we can write this as, okay, we can write this as W1, W2, sigma 1, 2. Okay? Right? This one is exactly the same as this one. All right? And last class is your, how about this 2-2 pair? So now we have Wi, Wj, so that's W2, W2, covariance of 2, 2, which is just the same as W2 squared and the variance of 2. There. Covariance of 2, 2 is just the same as the variance of 2. All right, therefore, we can now simplify that a two-asset portfolio, the variance of a two-asset portfolio is simply the sum of asset 1, the weight of asset 1 squared multiplied by its variance of 1, plus the square of the weight of asset 2 multiplied by the variance of 2, plus 2 times the weight of asset 1, asset 2, covariance 1, 2. Their class. Okay? So this is the variance of a two-asset portfolio. So take a look at the pattern, class. Square the weight of asset 1 multiplied by its variance. Square the weight of asset 2 multiplied by its variance. And then twice the product of W1, W2, and covariance 1, 2. Okay? All right. I'll allow you to, if you're copying notes, class, allow you a few seconds to copy notes. And if it's okay now, it's clear now to you, class, what is the risk in terms of variance of your two-asset portfolio? Kindly chat yes, please. Kung clear na, class. Or you have already copied the notes, kindly chat yes. Okay, thank you. Let's wait for the others to key in their comments. Okay, good. I hope everything's clear. So how do we compute, class? If I want to get the standard deviation, usually the measurement of risk is via standard deviation. How do we get that? How do we get that, class? Okay. Yeah, thank you, Vince. Just get the square root, class. So if you want to measure the standard deviation, which is usually the metric for the risk, just remove this and then just get the square root of this. There. Square root of this whole quantity. That will be the risk of your portfolio. Okay. Now, take a look at the pattern, class. Now, we can extend this to a three-asset portfolio. Very easy, class. Very easy. If we now know how to, if you know the general formula, again, let's go back to the general formula. So let's quickly just go over this. So the risk of a portfolio is equal to double summation of W sub I, W sub J, covariance Ij. Okay, I ranges from 1 up to n. So for a three-asset portfolio, it's the same, class. You can, the pairwise will be 1 with 1, 1 with 2, 1 with 3, right? And then 2 with 1, 2 with 2, 2 with 3, and then 3 with 1, 3 with 2, 3 with 3. And we know that this pairwise is the same. 1 with 1, 1 with 2, 2 with 1, it's the same. 1 with 3 and 3 with 1, it's the same. 2 with 3 and 3 with 2, it's the same. So you now have pairwise of 1 with 1, 2 with 2, 3 with 3. So these are the individuals, okay? And then you have the pairwise comparison of the pairwise of 1 with 2 and 2 with 1, etc. So how many terms will there be? 1, 2, 3, and then 4, 5, 6. There will be 6 terms, class, and it will be equal to, so the variance of a portfolio, of a 3-asset portfolio, will be equal to, okay, I'll just spell it out, class. No, I know you'll be able to get this. It's just the square of the weight one of your asset and its variance, okay, plus W2 squared, the weight squared of times the variance of asset 2, plus the weight squared of your asset 3. There. So that takes care of your asset 1, asset 2, asset 3, plus the cross product between your assets, okay? So this is plus 2 W1, W2, covariance 1, 2, plus 2 W1, W3, covariance 1, 3, and then plus 2 W1, W2, W3, covariance 2, 3. There you go. Okay. So please comment if this is okay, or if I'm going too fast, I will repeat, class. If you need me to repeat the formulation for the risk as measured by the variance of your portfolio. Clear? Okay. Waiting for the others, class. Okay. Good. So I want you to answer me, please, in yes or no. If I ask you to spell out the variance of a 5-asset portfolio, will you be able to spell it out, class? Okay, wait. My question is, 5-asset portfolio, class. Will you be able to spell out the variance or even the standard deviation of a 5-asset portfolio? Your chat, please, yes or no? Five asset. No? Five-asset portfolio, class. Will you be able to spell out just like this? Not yet. Spell out lang, ha? Just spell it out. No? Okay, kasi you can see already the pattern, class, di ba? This is a 3-asset portfolio. So if it's 3-asset portfolio, then you have the variance of each of the asset. Variance of 1 multiplied by the weight squared. This is your asset 2. This is your asset 3. And then you pair twice of the weights of the pairs, right? And its covariance. Okay, why do you have 2 here? Why do you have 2? Because we have 1, 2 here and 2, 1 here. We can add this. That's why you're getting 2. 1 and 3 and 3 with 1. It's just the same. Okay? W1, W3 It's just the same as W3, W1. Covariance of 1, 3 is the same as covariance 3, 1. Five asset portfolio class. Ang question ko lang naman, class, if you see the pattern here, will you be able to also write the equation for the risk of a 5 asset portfolio? Just a yes or no, class. Based on the pattern, class. I'm sure you will, class, no? Pattern lang naman siya. Okay, sige, define natin, class, the 5 asset portfolio. Okay, on your own, I'm sure you'll be able to do that, no? Kasi 5 assets, so you have asset, the variance of 1, the variance of 2, okay, 2, the variance of asset 3, the variance of asset 4, the variance of asset 5. Okay? And then you multiply this by its weights squared, di ba? Plus W weight ni 2 squared plus weight of 3 squared plus weight of 4 squared plus weight of 5 squared. So that takes care, class, of the variances of the individual assets. And then we take a look at the covariance. Okay? So just pair it. What are the pairs? 1 with 2. So that will be your variance of 1, 2. Okay, and then what else? 1 with 3, 1 with 4, 1 with 5. Okay, and then we have 2 with 3, 2 with 4. You don't go back to 2 with 1 because it's already here. It's the same as 1 with 2. 2 with 4, 2 with 5. Okay, and then you have 3 with 4, 3 with 5, and then you have 4 with 5. Those are the covariances. And then you just multiply this by 2 times W1, W2. Okay, right? This is 2 W1 times W3. This is 2 times W1, W4. This is 2 times W1, W5. And this is 2 times W2, W3. This is 2 times W2, etc. class. No? Okay, I don't want to belabor this anymore because it's so pattern friendly, class. No? Okay. All right. I'll ask you again, class. If I ask you to write the formula for the 10 asset portfolio, class, will you be able to write the formula for the 10 asset portfolio? Yes or no? Okay. Yeah. Thank you. Thank you. Good. I'm sure you can, class, because the pattern is so obvious. Okay. Okay. Now my next question is this. For a 10 asset portfolio, okay, for a 2 asset portfolio, how many terms do we have? For a 2 asset portfolio, how many terms do we have? Class? How many terms in the computation for what's that? 2 asset portfolio? How many terms? You have W1 squared, sigma variance 1, W2 squared, variance of 2, plus 2W1, W2, sigma 1, 2. How many terms? Yeah, 3, correct. 3. For a 3 asset portfolio, class, for a 3 asset portfolio, how many terms? 4 ba for a 3 asset portfolio, class? You have the 3 individual assets, and then you have the pair, 1 with 2, 1 with 3, and 1 with 2, 1 with 3, and 2 with 3. 5 lang ba? You have the 3 assets, no? And then we have pair 1 with 2, 1 with 3, and 2 with 3. Yeah, that's correct. That's 6, right? And then if you have 4, if you have 5, etc. Now you can develop a mathematical equation. If you have a 10 asset portfolio, how many terms will you have? If you have 2 assets, you have 3 terms. If you have 3 assets, you have 6. There's a formula for that, class, and I would want you to discover that So kindly research on that. But what I want, okay, for 5 asset portfolio class, how many terms? 5 asset portfolio. How many terms? You have 5 here, class. Huh? And then here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? You have 10 terms. 15 ba, class? Pag 5 asset portfolio. 1, 2, 3, 4, 5. And then the pairs, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's correct, no? I did not add the 5. So that's 15. Thank you so much. That's 15. And there's a formula for that, class. It's very easy, class, but I will not tell you that to you. You discover that, class. If you have a 10 asset portfolio, okay, of course, it will be more terms. All right. So may I ask you, class, what is the limitation of this model that we're doing? Can you tell me what's the limitation of this model? What do you think, class? Do you think if I gave you an assignment where you have 10 assets, do you think it will be easy to compute for the portfolio risk of that, class? What's your take on that, class? Yeah, okay. Si Jerome lang ang may answer na no. Yeah, Vince also, thank you. Yeah, correct. I agree with you. It will be time consuming. Imagine if it's a 5 asset portfolio, we have 15 terms to compute. Okay, and that's not easy, class. That's not easy. That's why, class, when you're computing for the portfolio, of course, now it's just a matter of asking R to compute for the portfolio risk. Very easy already, no? But I just want us to understand the quant behind that, because this is financial analytics, and it's important for us to at least appreciate. Okay, we might not be computing manually for the risk of the portfolio, okay, but at least we understand what's happening, the math, the little math behind it. Okay, so the formula for the risk, class, as we mentioned, is this, right? W sub I, W sub J, and covariance I sub J. Okay, summation. Okay, and this is very unwieldy. Okay, no problem if you just have 2 assets. That will be very easy because you have 3 terms. If you have 3 assets, you have 6 terms. If you have 5 assets, you have 15 terms. And you can easily compute if you have 10 assets, how many terms will there be? Okay, imagine wasting your time just computing for each of the term, where you multiply, where you square the W, you get the variance of your asset. Okay. The good news is this one, class, it can be easily computed using matrices. Okay, and this is what softwares use. They do not compute it by identifying each of the elements here, but rather they compute it using matrices. So the risk, class, of our portfolio can be written this way. It's your W matrix multiplied by your variance covariance matrix multiplied by your W transpose matrix, right? So this is the formula. This is the formula. So this is in matrix form. Okay, this is in matrix form. All right. So let's start with the two asset portfolio. Now the weight of the asset. Okay, I'm sure you have subjects before on matrices. Okay, a matrix is a rectangular presentation of your numbers. Okay, so your weight asset for a 2 asset portfolio, the weight should be 1 by 2, which means it should be 1 row and 2 columns. So your matrix should be written this way. So this is your asset 1, weight ni asset 1, and weight of asset 2. That's how you will write your matrix. W1, W2, this represents, for example, this is 10%, and this should be 90%. because the total weight should be 100%. And the dimension is 1/2. Now, this is your var-covar matrix. Var, I'll explain to you in a while why it's called var-covar. Var-covar matrix, and it's a square matrix. Since you have only two assets, this is a 2/2 matrix. All right? And then this one, W transpose, it's just the reverse of your W matrix. So if this is written as 1/2, what should be the dimension of the W transpose? Paki-chat, please, class. Kindly chat. If your W matrix is written as W1, W2, 1/2, what should be the dimension of your W transpose matrix? Should be? Okay. 1/2 transpose. Yeah, okay, I got one answer here. It's a 2/1 matrix. You're correct, no? So 2/1, class, transpose natin. In other words, this one will be written as this one, W1, W2, where the rows are now 2 rows. So this is now 2/1. Okay, so your 1/2 became a 2/1 matrix. All right, very quickly, class, in matrix multiplication, two matrices are multiplicable if, so this is the row 1, this is row 1 of matrix 1, this is its column. 1 row, 2 columns. So two matrices are multiplicable if the column of the first matrix is equal to the row of the second matrix. So this is 2 and 2, they're equal. So this can be multiplied. If they're not equal, you cannot multiply those matrices. And the resulting matrix is, if you multiply W with the sigma matrix, okay, it will be, the result will be the outer dimensions. It will be 1/2. Okay, so W times sigma results into a 1/2 matrix. And then we're multiplying it by the W matrix. The W matrix is a 2/1 matrix. Okay, question, class. Are these two matrices, the sigma, the result of W sigma, and your weight transpose, are they multiplicable? Kindly chat, please. Yes or yes, class? Yes or yes? Okay, I said yes or yes, huh? Okay, thank you. You're correct. It's yes, class, because the column of the first matrix is the same as your row of your second matrix. And what is the resulting matrix, class? The resulting matrix is this one. There. It's 1/1. Correct. Thank you. So your variance is just one term. Okay, where is my pen? The variance, class, it's a 1/1 matrix. So it's just one term, class. And what's that term? It's your W1 squared, variance of 1, plus W2 squared, variance of 2, plus 2W1, W2, variance, covariance 1, 2. We can show, class, mathematically that when we perform this, it will give us exactly this. All right? It will give us exactly that. Okay, I will not show that anymore, but okay. But it can easily be shown that, okay, explain ko, class, yung variance covariance, no? Kasi I haven't explained this. Your variance covariance is, in this case, 2/2 matrix. Where did it come from? Well, how many assets do we have? So it's 2 assets. So 1, 2, 1, 2. So here I'm defining what your var-covar matrix is. Capital sigma. Okay? So this is how you denote your variance covariance. All right. So you just take a look at this. 1 with 1. So you're asking us, what is the variance of 1 with 1? Okay. What is the covariance of 1 with 1? The covariance of 1 with 1 is your variance of 1, right? The covariance of 1, 1. So covariance 1, 1 is your variance of 1. How about this one, class? 1 with 2. It's your covariance of 1, 2. There you go. How about this? 2 with 1. 2, 1 is just the same as covariance 1, 2. right? Remember, commutative, doesn't matter if one comes first or two comes first and then one, doesn't matter, they're the same. And this one is your covariance, the variance of two or the covariance of two with two. All right, so this is now your variance covariance matrix. So the diagonals will be the variances, the off diagonals are your covariances. Okay? Okay, any questions so far, class? Clear ba, class, so far? Kindly chat, please, if we're clear. Okay. All right. Now, I will not anymore prove to you that if we perform this, for example, sigma squared p of your weight matrix, so you have the weight of 1, the weight of 2, so this is your first matrix. If you multiply that with your variance covariance, which is this one, variance of 1, variance of 2, okay, and then covariance 1, 2, covariance 2, 1, or covariance 1, 2, they're the same. And then you multiply it with this one, W1, W2, which is the transpose of this matrix. If you multiply this, class, if you perform matrix operations on this, it will give you the same answer as this one. The same answer as this one, the one that we spelled out a while ago. This one. Okay, I leave that to you as an exercise to try to see if indeed you'll get the same answer, but you will. So what's the advantage of that, class? The advantage of that is if you have a 10 asset portfolio, okay, it's very easy now to compute for that because you're dealing with matrices. So for example, for a 10 asset portfolio, W1, W2 until W10, right? So now this is your weight matrix. This is a 1 by 10 matrix. And then you'll have your variance covariance matrix. So that's variance of 1, variance of 2, until variance of 10. Okay? And then you have here your covariance 1, 2, covariance 1, 2, okay, etc. So this is a 10 by 10 matrix. It's called your var covar. It's called your variance covariance matrix. Why is it called your var covar? Because it consists of the variance of your assets and the covariance among the assets. Okay? And then you have now your W transpose matrix, which is the transpose of this one. So it will be like this. W1, W2 until W10. All right? And this is a lot easier to perform when you're dealing with the software. Very easy because you're just multiplying. You just specify this object, and this object, and then multiply. Okay, so you can now see that softwares like R make use of this. All right, so well, that's good because we were able to show, class. My intention was for you to at least now be able to, if you're asked for the risk of a portfolio, you can tell them that it's very easy actually. There's a formula for that. The double summation W sub I, W sub J, covariance of IJ, or using matrices, the weight matrix multiplied by the variance covariance multiplied by the W transpose matrix. Of course, we're not going to do that manually. We're going to let R do it. Okay? All right, is that clear, class? Do you now have a sense of how to compute the risk of a portfolio? Feedback, please, class. Feedback, please. Do you now have a sense of how to compute? Okay, at least formula-wise, class. No? We're going to now to learn how to compute that in R, and it's very, very easy, class. Okay, but at least you know what's happening. How in the world did we get that formula? For Fin students, class, especially those coming from our institution, from LaSalle. It's non-negotiable. We should know that, class. We should know that. So two ways, the double summation formula or just the matrix formula. Which is the better formula? Of course, it's the matrix formula because this is easier to calculate. Imagine if you're going to identify each of the terms here in the double summation. Wow, It will take us eternity. All right, it's almost time. And unfortunately, class, in the other class, we were able to at least, okay, let me, please load this in your R, okay? All right, so I'll just give you the codes. Okay, we don't have time to run it now, but this is as far as we went with the other class. I'll just give the codes to you now, okay? All right, kindly copy it in your worksheet. Okay, so let me just summarize what we'll be doing next week, on Monday, on Wednesday, on Friday, I mean. So here, we're using these packages, okay? Please take time to load it so that on Friday, it's already loaded. All right, and then we're going to download from Quant Mode these stocks, Microsoft, NVIDIA, IBM, Apple, Meta, and Amazon. Okay, because we're going to create a portfolio out of these stocks. We're going to compute for the returns. We're going to compute for the portfolio risk. Okay, the start date is defined here. Okay, and then using the get symbols function of Quant Mode, our symbols is equal to tickers. Start date, we have identified from is equal to start, to is equal to end, source is equal to Yahoo, and auto.assign is equal to true, which means that when we download this, R will automatically create these objects, Apple, Amazon, IBM. The name of the objects will be the same as the ticker symbol. Okay? All right, so it's already time, and we'll continue with this next meeting. Okay, let me just also include this, kindly copy this class. So this one, okay, also run this code chunk. We're going to merge, okay, take a look at this code. So we're going to merge now in one data, because here you have separate Amazon, IBM, Meta. But for this one, we're going to use the merge function, and we're going to merge the adjusted price for Microsoft, adjusted price for NVIDIA, IBM, Apple, Meta, okay, and Amazon. Okay, so let me just share this with you. Okay, so we'll start from this one next meeting. Okay, when we start our session next meeting class, make sure that you already have the prices, that data object loaded. Okay, so with that, we end our session for today. Okay, last question, class. We're able to learn something this afternoon? Class? Okay, good. Thank you. Thank you. Okay, so now, class, with confidence, you can now say that you know how to, you understand now how to compute for the risk of a portfolio. Okay, and we set out to do that today, and we were able to do that. That's good. Okay, thank you so much, everyone. I'll see you on Friday. Keep safe.
Thank you,
Thank you,
sir.
sir.
Thank you.
Thank
Thank
you,
you.
sir.
Thank you. See you on Friday. Thank you.
Sir,
Yes.
I have to show you yung case study number 1.
Okay.
Yeah,
Which
kasi
one?
my partner was the one who
Okay.
dropped the subject, sir.
Yeah, Ishan, can
So
we let's discuss later tonight na lang kasi may klase pa ako next, no? So
sige sir, no problem. Pero
tonight
what I did was I
i-PM mo
gave
ko
the outline. Sige sir.
Oo, sige.
Mga what time, sir?
Mga ano na, kahit mga 8 or 9 na. Later tonight na.
Okay.
Gising ka pa nun?
Sige sir. Ha?
Gising ka pa nun?
Yeah. I'll be awake
Baka
pa naman,
nagbe-beauty
sir.
rest ka na nun eh.
Hindi pa naman, sir. And tsaka for the next case study, sir, can I just join another group?
Yeah. We will reshuffle the grouping.
Okay. Sige,
Okay.
sir. Thank you.
All right,
Thank you.
Ishan, thank
Bye-bye.
you. PM mo ko mamaya, don't forget.
Yes, sir. Thank you, sir.
Okay,
Bye-bye.
sige. Thank you. Bye-bye.